Hello, Assalamualaikum guys. Today, both of us want to present about RUDDERVATOR and CANARD. So, Najwan will present about RUDDERVATOR and Luqman Hakim will present about CANARD.
Hello guys, my name is Najwan and I'm gonna explain about RUDDERVATOR. Okay, so first thing first, RUDDERVATOR is a combination of two primary flight control surface, which is rudder and elevator, part of a VTOL configuration.
Hello guys, my name is Luqman Hakim. I will present about CANARD. So CANARD is forward control surface. This means it is placed at the front of the aircraft, ahead of the main wings. Its purpose is to help control the aircraft motion, especially pitch the up and down movement of the nose.
Okay, now let's move to design and structure. For a RUDDERVATOR is a movable surface attached to each side of VTOL. Instead of having separate horizontal and vertical parts, the VTOL consists of two surfaces mounted in V shape. Each surface moves together and acts as both an elevator and a rudder. They are usually made from aluminium or composite material.
So, design of CANARD is small wing like surface ahead of main wings. In terms of design, a CANARD looks like a small wing position in front of the main wings. Although it's small, it plays a significant role in stability and control during flight.
For the function of RUDDERVATOR is combined of two functions, which is elevator and rudder. As we know, elevator function is control pitching up and down, and rudder control your wing left and right.
CANARD function is primarily control pitch at lift and improve stall behavior. The main function of the CANARD is to control pitch. It helps raise or lower the aircraft nose. It also adds lift, reducing the load on the main wings. In some design, it stalls before the main wings, which help the aircraft recovery smoothly and improve safety.
For the operation of RUDDERVATOR, when both RUDDERVATOR move up or down symmetrically, they act like elevator. When the RUDDERVATOR move up, tail gonna be down and nose gonna be up. When RUDDERVATOR move down, tail gonna be up and nose gonna be down. For the yaw control, when they move asymmetrically, which is one up and one down, they generate differential lift, causing the aircraft to yaw left or right like a rudder. This vector combination of movement allow the VTOL to manage both axes with favor parts.
In operation, the CANARD works like an elevator. It moves up or down depending on the pilot's pitch input, adjusting the angle of the nose.
Okay, now let's move to the location. RUDDERVATOR location are located on VTOL at the rear of the aircraft. The VTOL extends diagonally upward and outward instead of the traditional vertical or horizontal tail surface.
The CANARD is located at the front of the aircraft, ahead of the center of gravity. This forward position gives it an active role in flight control.
Okay, now let's move to control input. We have two of control input, which is manual control and automated control. For the manual control, pilots control the elevator via the yoke or stick, pulling back to raise the elevator to raise the nose up and pushing forward to lower the nose down. For the automated control, in modern system, autopilot and fly by wire computer send the electrical signal to actuator that move the elevator, often without direct mechanical linkage.
The canard is controlled by pitch input from the pilot. In modern aircraft, it is usually managed through a fly-by-wire system which uses electronic signals to help maintain precision and stability.
Okay, now let's move to the configuration, which is we both have to discuss how different aircraft use this component, which is traditional versus modern aircraft. So, the traditional aircraft use separated rudder and elevator control surface. V-tail aircraft use ruddervator to reduce drag and weight, require a mixer mechanism to convert pitch and yaw inputs. For the modern aircraft, which is fly-by-wire, in modern design, mixing is done via software and allowing more precise and efficiency of control.
Canard configuration, Saab Viggen, Eurofighter Typhoon and Dassault Rafale, a Gulf fighter jets with canard configuration. These small front wings boost maneuverability, improve control and give the edge in aerial combat.
The last one is a real-world application and example. As you can see, Beechcraft Bonanza V35, a well-known general aviation aircraft with a V-tail and ruddervator. For the advantage, lighter and has less drag than traditional tail design. Fewer control surface equal to simpler maintenance. For disadvantage is more complex control mixing required and potential for adverse yaw or reduced effectiveness in certain flight regimes. The failure is a malfunction in mixer mechanism, which can lead to loss of pitch and yaw control simultaneously, which is critical.
For real-world applications and example, we can see canards in fighters like the Eurofighter Typhoon as well as in experimental and early aircraft.